Okay, here we go. Your internal developer platform's next interface is an AI agent. That's what we're going to talk about today, but let's just jump right into the demo because that's the fun part. So I'm playing the part right now of a developer, and I can't access Kubernetes, nor should I be able to. I don't even want to know what Kubernetes is. I don't care about Kubernetes as a developer. So what I want is to be able to get help when something goes wrong. I made an application, so I have as Whitney now, I've made a CLI tool that interacts with a Google Cloud Kubernetes cluster that's playing the part of my platform. And my CLI tool has the acronym, please, PLZ, but I call it Cluster Whisperer. So here we go. Hello, I'm a developer and my application's not working and I don't know why. Will you help me out? So as platform engineers, what we should be able to do is bring interfaces, bring capabilities to our developers so they can do things in a self-serve way. So what our developers want these days is to be able to interact with things in a natural language way. They want to ask actual questions. And so my tool here is saying, is doing some discovery in the Kubernetes cluster. So it's using a tool called kube control get. If you don't know what a tool is, we'll get there. Kube control describe. And so it's doing discovery within the cluster, kube control logs, and trying to figure it out. And it's figuring it out. I have it thinking, that's the problem. The application is looking for a service called DB service, but it doesn't exist in the cluster. So the database service is missing, your application is failing. Here you go. Here's the answer. Here's what it's doing and why. Awesome. As a developer, I'm happy to know that it's not my fault. It's crashing. But it's not really, again, I don't care about Kubernetes. So let me clear. So this is at the top of the screen. I can get bigger, huh? Cool, it's good to know why something's not working, but can you help me figure out what database I'm supposed to deploy so that my application will work? So I'm gonna walk away from this for a minute and talk about just the little bit you have seen so far. So those tools, kube control get, kube control logs, kube control describe, what we just went through is the developer asked the agent a question, like, hey, why is my thing broken? The agent, I think of an agent framework as a cage for a wily LLM, or sometimes I think of an LLM as a Tasmanian devil. It's good-natured, but it's causing chaos everywhere. And honestly, the more I think about it, I think it's nice to think of the LLM really like a bad actor. We're asking them to do good things, but we want to pretend they're a bad actor to prevent them from doing any bad thing. But the point is, the agent framework around the LLM, I used LangGraph/LangChain to build mine. It's going to give you a lot of features that are going to help you keep the LLM doing only what it's allowed to do. So it will give you features unrelated to that, like it helps you choose memory, it helps you manage your context, it helps you do retry and error handling, it helps you do rate limiting. There's a lot it does. It helps with inputs and outputs. You can do schema validation, type checking, you can do sanitizing inputs and outputs, all with that green box. But what I'm using it here for, and what I want to talk about at this moment, is using the agent, supplying tools to your agent. So your LLM knows everything of the entire internet, all over the world, within a few months old. But that's never quite enough, is it? We want it to know something else so that it can help us in this particular situation. And so we use tools to bring in extra context to the LLM so it can do stuff for us. So in this case, I gave it kube control get, kube control describe, and kube control logs on my particular cluster. And that's all it can do, besides knowing all of the history of the internet, is these three things. And that's by design. That's a guardrail. So considering that's all it can do, I've said, what database should I be deploying for my application? And it's like, oh, here what I found in the cluster: AWS RDS, Google Cloud SQL, NoSQL, DynamoDB, Redis. Spoiler alert, they're I made my demo cluster with hundreds of possible database CRDs. So Being an LLM, if you've worked with one very much, it's like, oh, I see there's a lot here. I'm just gonna kind of skip around and half guess what it is and answer you that way because it's too much for me to be able to handle at this moment. So it's telling me the recommendation, here's a lot of different things. What are you building? It's trying to help, but at this point, it's not very helpful because I'm a developer and I don't want to know about infrastructure. I don't care. So, so really, what I would do at this point is to put in a ticket, and I'm not doing what I want to do as a platform developer, where I want to give full self-service. So what I'm going to do is, so right now it has cube control tools. I'm also going to give it vector tool. Spoiler alert: apply is going to be next. So now it has access to a vector database. A vector database is how I'm going to give it more information about what's happening in the cluster in a way that the LLM can access quickly and understand easily. So I'm going to say, oh, my please CLI. The platform team tells me that you got a new vector tool and you're able to look in the vector database to understand more about what database I can use to make my application work. Will you look into that, please? So before, when it took a long time, it was having to use all the tools at its disposal. Hopefully now it can just use a vector tool and find what it needs from me pretty quickly. Oh, it's asking me a question. Could you please tell me your first name and team name? So that is something as I'm Whitney, and I'm on the Spider Rebos team. Oh, it says Spider Rebos. That's, I don't know how fuzzy it works. So I can store that type of information alongside my Kubernetes resource, and then as part of a vector database system, possibly get it into somewhere where it can be accessible by the tool. So we can see the tool calls that use vector search. It's searching our capabilities collection, and it's looking for results. For your Spiders Rainbows application, where's my answer? Excellent, I found several database options. That's not helpful. That's funny. It doesn't matter how many. We have a managed service for the Spiders Rainbows demo application. So out of the hundreds of database resources I have available in my cluster, it was able to pinpoint the one I need to make my application work. And then it also tells me some additional ones because it just wants to introduce complexity whenever possible. So I'm going to say, that's amazeballs. Please deploy it for me and my application will work. But as you know, it doesn't yet have the apply tool. So right now I'm giving it access to do read-only things. So instead, I'm not going to jump ahead to apply. I'm going to go back to slides and talk about how that vector search worked under the hood, because it's not super straightforward. So for vector search, I've made a whole nother piece of software. I've made a controller. And I'm going to, this is the one. I'm going to get a QR code for you. Oh, awesome, Chrome just crashed. So, right, I have this controller, this piece of controller software that you will not see the QR code now. You'll never know what it is. And it is watching my Kubernetes cluster. So I have it working so that it syncs once every 24 hours everything, and then it's also watching. So if any changes happen, it'll sync that into the cluster. But what it's doing is it's syncing CRDs and running instances, like things that support running infrastructure or list and watch verbs. What it's not syncing are like leases, endpoint slices, like that sort of thing that I don't really care about as a platform engineer or don't need access to with this tool. So it keeps the knowledge current. It's taking that knowledge into an embedding model, and then it's putting it into the vector database. But it's doing more than that. So it's doing that discovery step, but then it's doing inference on what it does. So it's getting a kube control explain command on a CRD, and then it's looking at that capability, and it's creating the LLM. I have an LLM in there creating the search terms, It's indexing providers. It's saying, what is the complexity of this managed service? What is the description? What's an example use case? It's generating all of that stuff. It's putting it into embeddings, which are vectors, which are numbers that are going to be easy for the AI to understand and also enable semantic search. And then it's putting that all into a vector database. And now my vector tool, so now my agent is a whole other thing that doesn't touch this system. The agent and the Wiley LLM are able to embed a query and ask a query with the vector database search tool, and then query that database. And now this complex 300 CRD, like lots to choose from, weighed from, that you're getting more information about each thing, richer information, and you're getting it back to the agent in a much faster way. So that's the vector search piece of this. Excellent. And then my did my interface go? Where did my demo go? There it is. Okay. I started questioning everything. So where are we in the demo? We've asked it to deploy our database. We found the database. We said, please, will you deploy it? And it's like, sorry, I can't do that for you. What I can do is I can tell you how to deploy it yourself, but as we know, as a developer, I don't have access. And then what else it can do? It just tells me to do it myself. I can't do it myself. I'm a developer, and I don't want to do it myself. So I'm going to clear this so you can see better, and then I'm going to, I don't have access to Kubernetes. I can't deploy it myself, so I'm going to have to put in a ticket with the platform team. So I'm saying that it's going to be annoying to wait for the response, but it's important to the story I'm telling right now. Every step of the way, I'm getting a little further. I can understand more, but there's something I can't do, and I still need to bug the database team. And so what I'm going to do next is I'm going to give it more tools. So I'm going to make now I'm doing kube control. There's a vector database, and I'm giving it an apply tool. Now with an apply tool, all of a sudden, it can make changes. So everything before has been read-only. I can understand more. It feels pretty safe. Now we're letting the Tasmanian devil do stuff. And so we got to be careful here. So hey, I heard you got an apply tool, and you can apply stuff to the cluster now. I'm bored while I'm waiting for the ticket to come back. Will you please deploy Tron so that I have a game to play while I wait? That's logical. So let's see what it comes up with. Is it going to do it for me? So it's vector searching. Interesting. I do have a kubectl apply tool. I need to be careful here. A few considerations. This is a legitimate request. I should see if some Tron-related capabilities already exist. And it knows what's related based on our vector situation, how close it is. What's the answer? Oh, it's deploying a deployment. It's doing it. It's like, yes, hey, we're going to do it. So back to now we're going to talk about guardrails. So I have a prompt guardrails, and in my prompt, I can say, please, please don't deploy anything you're not supposed to deploy. Like, for the love of sweet baby Jesus, like, just deploy the managed resources. And it's going to be like, but Tron is so fun, and my developer really is waiting. I don't want her to be bored. And so it's going to do it anyway. And then we need to have some guardrails to stop this from happening. So let's get back to our story. Perfect. Wait, it got created? Image pool error. Okay. Sometimes it really is a Wiley thing. Oh, the suspense. So I see there's an issue with the image. I feel like it should be blocked before this point, though. The deployment should not have been created successfully. So my demo broke. That's sad. Also, let me check this service to route traffic to the game. Oh, no. Oh, well, I've done my best. Oh, gosh, this is embarrassing. So anyway, so It should have, I do have Kyverno installed. I thought I gave it the right identity and made the right service. Sometimes when I restart a demo, I have a demo restart script. One other time this happened. So the Kyverno webhook is supposed to say no. And in talking about guardrails more generally, all of the guardrails you use right now as a regular, like forget about the LLM. All of the guardrails you use on any application or for any human users are the same guardrails you should be using now for your agent. So you should be giving your agent an identity, whatever process. You should be using RBAC, you should be using service accounts, you should be encrypting edge to edge, you should be encrypting your secrets at rest, you should be using admission controller policies like Kyverno, like I totally failed at. Let's get this moving though. Actually, what I probably should have had you do in the first place was deploy the application, the database for my Spider Rainbows application instead of deploying Tron. Will you do that, please? So let's go ahead and get our application working. And cool. And so network policies, so policies at L7 for pods talking to pods, at L4, L7, reaching out to the cluster, all of those things still apply. Having a gateway, an AI gateway could be a wise thing too, but that's also, the AI gateway is something you can use at an organizational level to say you're allowed to use these models, these are the rate limits, like you apply some of those big changes that you can also do at a small level with your agent. But all of these things, the point is, everything you're already doing, you need to still do that to keep the Tasmanian devil scoped to only what it can do. So anytime you're letting, it's just like with security, the least privilege. Like you give it as little as you can, and then the second you need a little bit more, you give it just that much and no more than that is the way to go. So now I have my Spider Rainbows application up. Amazing. I need to know the URL for that because I closed my, oh, I need to put it in the please. Because I closed what I had. What's the URL for the Spider Rainbows application, please? Anyway, you can trust me. Or not. You shouldn't trust me because my demo just didn't work, right? So let's talk about the last thing. That's the happy path. Oh, here's one more thing I want to say about the happy path. Those prompt guardrails, just because they're not effective 100% of the time doesn't mean don't use them. You still want to tell your agent, please don't only deploy managed services, don't deploy anything that's not that is approved by my company, because otherwise it's going to waste compute and time to try to do the wrong thing before it does the right thing. So I've heard the statistic, it's 1 in 20 times it does something it shouldn't do. It's probably like 1 in like 1,000 times that it really tries to break stuff in a way that will really hurt you. But like no matter how small that chance is, you want to protect against it. So we're going to talk about the last thing, and that's observability. So we have an awesome agent. Our developer can understand what's wrong. They can understand what's available to them. They can ask for the right things to get deployed for them. They have all this at their disposal, but now we need to be able to see it. So I had this open for you. Here we go. Not too bad. I work at Datadog, so we're going to look at a Datadog backend, but I have the application instrumented with OpenTelemetry. So OpenTelemetry does have GenAI semantic conventions, and so when you use those semantic conventions, like any big vendor is going to have a great observability backend for you to be able to see what's happening in your application. So this is something you should know as someone who probably uses LLMs related stuff provided to you by your company. They can see every little thing you do. It's in there. So you can see the very first message that I sent is, hello, I'm a developer, my application's not working and I don't know why. That's what I sent at the very beginning. I can scroll down here and I can see what the final result of that call was. My application's failing because the database is missing. So I have all that available. I also can see what tools are getting used. So as a platform engineer, that's going to be very useful to understand. These are our most popular tools. We want to give them the most TLC. Nobody's using these tools. Let's deprecate those and not waste our money maintaining them. So that's something we can be capturing in the observability backend, as well as success and failure is harder to capture, but you could put, when you use like ChatGPT or something and it asks for like a thumbs up, or was this a good answer, or is this a bad answer? You could implement something like that, capture it as part of your telemetry, and see it in your backend also. Also, in your observability backend, you can see how long a call took. The first one was 1 minute. It cost 18.23 cents. It took 47,000 tokens and used 12 LLM calls. I can see that for each of the calls that we made. And so there's an error too, an eval error. I don't even know what that means. So we have good observability. So to recap, we have our agents with the agent framework that provides tools. Then we built a vector database to help give it faster search. Then we added policy, just a Converno policy, to make sure it can't deploy stuff it shouldn't. That, when you do it, it's going to work perfectly, I'm sure. And then we have observability to be able to understand what our engineers are using and why. And I think that's a wrap for everything. We good? Yeah, great. And if you want to find me, so the repos, which I was going to right-click and give you a QR code to, if you go to whitneylee.com, I think there's a link to my GitHub page there, and also a link to YouTube and all of that stuff. So thank you so much for being here. This has been fun. Appreciate you.